Alright, in the last video, we actually created the batch renderer. And in this one, we're actually going to try to put it to use because we didn't get to use it. So what we're going to want to do is create a new system, and we're going to call it the render system. So new system, render system .h. And we're going to include our registry. And we're going to include our new batch renderer. So include rendering, not buffers, core batch render. And we're going to have our namespace, Scion core systems. And then we're going to have class render system. We're going to have some private variables. It's going to be private, and we're going to have our registry as a reference. So Scion core ECS registry reference, and we'll call that the M registry. Then we're going to have a unique pointer of our new Scion rendering batch renderer. We'll call that MP batch renderer, and we'll have some public, and that's going to be our render system, and that's going to take in a reference for the registry. That's it. And then we're going to have our render system destructor can just be default. If we need to change it later, we will. And all we need is an update. Void. Oh, should we call it update or render? We'll call it update. Cool. So let's create these functions. Awesome. So let's go to our render system. Change this really fast. Okay, and we're going to have to set our registry and registry because all references must be initialized, and then we go MP batch renderer. We just set this null pointer for now. Okay, and we can just create our batch renderer right now. MP batch renderer is equal to std make unique batch renderer. Sorry, we need Scion rendering. Actually, you know what? Let's put that up here. Let's go using namespace Scion core ECS. Now we can go using namespace Scion rendering. We're also going to need, while we're up here, we're also going to need the asset manager. Include the, so that's in resources and asset manager. And we're also going to need the camera. And that's in core. And we're going to need the shader. Rendering. Essentials shader. Do we need texture as well? We might not even need the shader, but we'll get that for now. And we're also going to need a couple of components. We'll get those. We're going to need our sprite component and our transform. Might as well put our logger in as well. All right, I think we're ready. Now we're making our pointer for our batch renderer, our unique pointer. And in our update, so our update is going to make similar use of the registry that the script system did. However, we're going to want to filter out the types of entities, and this time we want to have the transform component and a sprite component. So we can go auto view is equal to m registry, get registry, view, and we want the sprite component and transform. We also have to get the camera and the asset manager from the registry, and then the sprite shader from the asset manager. So we can do that now. We can go auto reference camera is equal to m registry, get context, std shared pointer, camera 2D. And then we also need to get the asset manager. So auto asset manager is the same idea. Get the context, and it's the asset manager. And we can put that up here as well. It's Scion resources. Cool. Now that we have the camera and the asset manager, we're going to need to get the sprite shader from the asset manager and then the camera matrix from the camera. So we need to go auto reference sprite shader is equal to asset manager get shader, and I believe we called it basic. We could change that to sprite later on. And we go auto camera matrix is equal to camera get camera matrix. So let's quickly check to see if the sprite shader was actually set up correctly. Sprite shader dot shader program. Whoops. If it's equal to 0, let's just leave. But actually I set an error for that. Whoops. And we can just go Scion error sprite shader program was or has not been set correctly. So now we can enable the shader. So enable the shader. And we go sprite shader dot enable and sprite. Now we want to set, let's get rid of this, sorry. Now we want to set our uniform, set our projection, so our uniform map 4. So sprite shader dot set uniform map 4, and we're going to set that to, I believe we called it U projection and cam map. Okay, so now we have our camera set up, we have our shader set in our uniform projection. Now we actually want to start batching. So we can go MP batch renderer begin. And now we want to loop through those entities that we just got. So we go for const auto. Actually, you know what? We can move this. This doesn't need to be here. Let's move this down here. Cool. Const auto reference entity in the view. And the first thing we're going to do is get the transform. So we go const auto reference transform is equal to view dot get transform component, and you got to send in the entity. And we can do it with the sprite component as well. Sprite component, we want to get the sprite const auto sprite. It can be const because we're not going to be we're not changing anything here. This is not where we do our changing. This is where we're only doing rendering. So the first thing we can do here is check to see if the sprite texture name is empty. Did we even give the sprite a texture name? So let's go if sprite dot, it doesn't have a texture name. So we need to actually go back to sprite component and give it one. So in sprite component right here, we can just go std texture, actually string texture name. And that can just be initialized to an empty name. Okay, sorry, let's go back here. So now let's check to see if the texture name is empty. So if the texture name is empty, we can just leave because it has no texture. We don't want to leave the function, but we do want to continue and go to the next entity. So we can go continue. If the texture hasn't been set correctly, we can just leave. So now we want to create the sprite rect and the UV rect from the transform and the sprite. So let's do that now. So we can go glm vec4 sprite rect, and we just initialize like this. We go transform dot position dot x transform dot position dot y. Now we're going to send in our sprite dot width and sprite dot height. Okay, and then we can do our UVs. So glm vec4, and that's the UV rect, and that is sprite dot UVs dot U sprite dot UVs dot V sprite UVs dot UV width and sprite dot UVs dot UV height. Beautiful. But before we even do that, let's grab the texture from the asset manager and make sure that it was set up correctly. So let's go const auto reference texture. So you go to asset manager, get texture. Now this is now based on the sprite texture name. So if we go if texture dot get ID is equal to 0, well, there's no need to keep going because the texture hasn't been set up correctly. So we go Scion error texture, and we'll send in the texture name was not created correctly, and that's the sprite texture name. Or you could put doesn't exist, because it might not exist. All right, so now the fun part. So now that we have the sprite rect and the UV rect, we now need to make any of the adjustments that are necessary. So if there is a scale or rotational change, we can do this with the model matrix that we were talking about before in the batch renderer here. In add sprite, we're sending in the model. So what we're doing is we're doing all of our translations, rotations, and scale with the model matrix. What we want to do now is go glm mat4, and we'll call this model, and we'll start it off as an identity matrix, or just 1. We don't want to change anything unless there's a rotational change or a scale change. So let's check to see. So if transform dot rotation is greater than 0.f, or transform dot rotation is less than 0.f, or transform dot scale dot x is greater than 1.f, or we can do all this dot y, or no, dot x, sorry, is less than 1.f, or copy this line, the same for y. Now we want to do all of our stuff to our model matrix. We're going to want to translate the model to the position of the transform itself. Now we also want to translate a little bit halfway so we can account for the rotation. So we go model is equal to glm translate, and we send in the model, and it's glm vec3 That is our transform dot position and 0.f. So we're basically translating the model to the transform position. Then we go model is equal to glm translate model glm vec3. And here we want to move halfway of the sprite times the scale. So we want to move it halfway forward times, so we go sprite dot width times transform dot scale dot x, and we can put this in a bracket and times that by 0.5 for halfway. And we can do the same thing for the y and height. Scale dot y, and instead of width it's height here. And because this is a vec3, we can put 0.f. Did I miss something? You guys probably already see what I did wrong. Ah, yes. This needs to be here. So now that we've translated it over, we can now rotate. So we go model is equal to glm rotate, and that's model based on, we want to say glm radians and transform dot rotation. So what glm radians will do is it'll take our degrees, it says it right here, and it will change it into radians for us. And then we want to send in our glm vec3, and that's just going to be 0.f, 0.f, and 1.f. So after we're done our rotation, we can actually do this one back. We have to translate it backwards. So we go translate, and this is times -5 times -5. And now, after we've done our rotation, we can do our scale. So we go model is equal to glm scale model glm vec3 transform dot scale and 1.f. Okay, we're almost done. One more. So we have to translate it. Since we translated it all the way to the transform position here, we actually want to translate it back. So we go model is now equal to glm translate model glm vec3 minus transform dot position 0.f. All right, so there, our model matrix is ready. Beautiful. Now we can actually add this sprite to the batch. So we go m batch render, add sprite, sprite rect, uv rect, texture dot get id, then sprite layer. We don't have a sprite layer. We're gonna have to create that too. Then we're gonna have to go model and sprite color. So real quick, let's go back to this sprite and create the layer. So where's our sprite component? And we need that there. Layer, and it'll start at the 0. Cool. Back in the render system, so we're adding our sprite. Okay, so now outside of our for loop, we can go mp batch render, and this will generate our batches for us, and then mp batch render, and it will be rendered. And now we can disable the shader. So sprite shader disable. All right. That's it. That's the render system. So now we actually want to move the render system into the application. So let's go do that now. Let's go to application. Let's clean it up a little bit. Let's go to application.h. We can get rid of this. We don't need that anymore. Go over here. Let's start clearing things out. Yeah, so all of this can go. Let's get rid of that. Let's get rid of this. Actually, let's get rid of everything in here, except for the script system. We'll leave that. Because all of that is now done in our render system and batch renderer. So we can actually remove all that stuff. All this stuff up here, all these vertices, we don't need these anymore. We can get rid of that. And generate UVs, we can leave that. What else can we get rid of? We already took away everything, I think. Okay. So up here, let's actually add in our render system. And right below our script system that we're adding in, wherever that is, script system, let's add in our render system. We'll just copy that. And copy this, and we'll just change it. I know it's not good to do this, but we're gonna do it. Render system, render system. If not, render system. Failed to create the render system. Add to context. We want to add the render system, and we'll send in the render system. And then fail to add the render system to the registry context. Okay, so now we actually have to set our texture and our layer in our test entity, where are we doing that? In our, right here. So start height, so layer, we'll just have it equal to 0. And texture name is going to now be equal to castle. I believe that's what we called it. Where do we add that in? Right here. And we're generating UVs. Good. So we won't need any of this anymore. This can all go. We can leave that. All right, do we still have some? And we don't need any of this anymore. And we just change this to, even this can go. And this can change to, now we want to get the render system. Shared pointer, Scion core, systems, render system. So that will get us our render system. And down here we can go render system update. Maybe I should change that to render, just so it is the same. We don't need this anymore. That's all done. And let's see if that works. We should have our eye on the screen. Now we didn't build in the last one, so this one might not build either, but let's take a look and see what happens. Awesome, our eye is there. We're rendering from Lua, and that's actually in our batch system. So we're using our batch. If we go here and stop it here, bang. So our numbers, we only got one sprite, all the information, bottom left, top right, layer, texture ID. Beautiful, cool. So that's our render system. So let's actually try something really fun. So we got our render system working, we got our batch renderer working. Let's see if the rotation and all of that is working. Right now we are scaling based on the camera. So where's our camera? Where do we scale that? Sorry, in the batch render. So we're doing that in the application, wherever that went, application.cpp. Our camera is the one that is making the scale large. So let's get rid of that. Now that should bring it down to 16 by 16 pixels. It should make it really small. Awesome. So if you see there, the scale is really small. Let's go into where we're creating our entity and set the scale now. Let's set it to 3. So it's 3 times the size. Awesome. So the scale is working. It's 3 times bigger, and that's being done in our render system. Let's see if the rotation works. Let's set it to 45 degrees. And it should be rotated 45 degrees. Awesome, we're rotated 45 degrees, and that's all being done in our render system. So let's now just change this back to 0. Let's do something real fun really fast. Okay, so now in our update, let's go to our update here. So we're rendering, we don't want to touch that. So let's go here in our update. So right after our script system's updating, let's actually, just for fun, go auto view MP registry. Get registry, view. We want to get the entities here. Let's go Scion, core, ECS, and I want the transform component and sprite component. Okay. And we're going to have a few static variables. Remember, we're not going to use this. This is just for demonstration purposes. So let's go float, and we'll have the rotation. And that'll be 0.f. And then let's have static float xpos 10.f. And we'll have static bool, oh man, bool move move right, and that'll be true. We want to start moving right. So let's go if rotation is greater and equal to 360.f. We'll clamp it, we'll set it back to 0. And then let's have it so if we're moving right, if B move right, and xpos is less than 300 per se, we're going to say xpos plus equals 3, else if move B move right and xpos is greater and equal to 300 dot f. We just say greater. Then we say move right is equal to false. And then let's have another one. So we go if not move B move right and x pos is greater than 10.f, x pos minus equals 3, else if not moved right and xpos is less than 10, we'll set move right to true. So it'll basically just be going back and forth. Cool. So let's go through our view. Let's go for const auto reference entity in the view. And we're going to want to create an entity. So go Scion, core, ECS, entity. We'll call it ent. That's sending in our dereferenced MP registry and the entity. Then we go auto reference transform is equal to ent.get component, Scion core, ECS, transform component. And now we want to set our rotation. So transform.rotation, transform.rotation is equal to rotation. And then transform.position.x. We're only changing the x pause here, so we go x pause. And if it's rotating the one way, if it's rotating right, we'll rotate it 9 degrees. If not, we'll rotate it the other way. So rotation is equal to, let's say plus equals b move right 9. So if we're moving right, we'll change by 9 degrees. If we're not, we'll change by negative 9 degrees. So we'll go the other way. All right, I think this will work. Let's try it out. Awesome. Okay, so we messed up somewhere here. Let's fix that real quick. It should be going back and forth. We'll say less than equals, greater than equals. I think that'll fix it. Unless I'm missing something else. There we go. Awesome. So now we're rotating, we're scaling, we're able to translate and move our object. This is all being done in the batch renderer. And we're also able to see that we're reading our scripts from main.lua. So we're actually starting to make some progress. We're starting to see some progress now. In the next video, we're actually going to start looking into reflection. So ENTT has its meta side, which is basically runtime reflection. And we're going to be needing that in order to get the be able to see the components and all these things at runtime. So you'll register these components using meta. And we'll go over that in the next few videos. Okay, so hopefully you like that video. Please like and subscribe. If not, let me know if there's anything I can change. Have a great day. Take it easy.